Picture this. You're watching your kids sprint down a wet soccer field.
Oh, yeah. Every parent knows that exact feeling.
Right. And they're just giving it absolutely everything they have. But then suddenly, an awkward pivot, a slip, and they go down hard.
It's terrifying.
It is. In that moment, I mean, you'd pay any amount of money just to know they're okay. And tech companies, well, they know this.
Oh, they absolutely do.
And right now, they are selling youth sports leagues, this $3,500 a year artificial intelligence system. And it promises to predict that exact injury weeks before it even happens.
Which sounds incredible, right?
It does. But we have to ask, are we actually protecting kids, or are we just, putting a massive paywall around their safety?
That is literally the multi-million-dollar question hovering over youth sports today.
Yeah.
Because we are seeing a massive influx of AI tools designed for injury prevention.
Like what kind of tools specifically?
We're talking about complex movement analysis, load management tracking, these really advanced wearable biometric sensors. The technology is advancing at an astonishing rate.
Yeah, I've seen all the ads for these.
Right. And the marketing pitch to parents and coaches is incredibly seductive. I mean, who wouldn't want to prevent their kid from getting hurt?
Exactly. But are we getting blinded by the shiny new tech?
Yeah.
Because today, our deep dive is focusing on a really thought-provoking article by AI expert Johan Steyn. It's titled, AI in Youth Sport Needs an African Reality Check.
It's such a brilliant piece.
It really is. And our mission today is to cut right through that tech utopian hype. We're going to figure out if these flashy AI tools actually make sense outside of, elite wealthy bubbles.
Because they often don't.
Right. We need to look hard at the harsh realities of affordability, access, and fairness, specifically in developing contexts like Africa.
Which is just a necessary lens to look through. I mean, innovation isn't truly revolutionizing a field if it only functions in a vacuum of unlimited resources.
Okay.
Steyn is challenging us to examine the massive gap between what is technically possible in a laboratory and what is practically viable for the vast majority of the world's children who, let's be real, just want to play a game.
Okay, let's unpack this. Because reading through Steyn's perspective, I couldn't help but think of this analogy.
Let's hear it.
Strapping a 10-year-old child with a suite of elite AI biometric sensors is kind of like, it's like buying a multi-million-dollar Formula One telemetry system for a teenager who is just learning how to drive a beat-up used sedan.
That is spot on.
I mean, yes, it is incredibly cool technology, but it completely misses the point of what that driver actually needs right now to safely get down the road.
To understand that disconnect, though, we first have to understand the baseline this technology is coming from.
Right. Where did it start?
Well, if we look at the Deloitte 2026 Sports Outlook, they detail how elite professional sports are utilizing AI. At the highest levels, think the Premier League or the NFL AI isn't a novelty anymore.
It's just part of the routine.
It is deeply integrated into every single practice.
Wait, break that down for me. What does that actually look like on the field? Like when we say biomechanical data or load management, how is the AI actually gathering and using that information?
Okay, so at the elite level, it starts with an array of high-speed cameras surrounding the pitch.
Okay.
These cameras feed video into an AI system that maps the human body. It's often tracking, 33 specific joints on every player simultaneously.
Wow. 33 joints at once.
Yeah, on every single player. It creates this digital stick figure of the athlete in real time, and the AI is looking at the microscopic angles of those joints.
So it sees things a coach couldn't possibly see.
Exactly. So when a player jumps for a header and lands, the AI measures the exact degree of bend in their knee. If that knee collapses inward by even a fraction of an inch, which is something called valgus, the system flags it as a high-risk landing pattern for an ACL tear.
Jeez. That's the movement analysis part, right?
Right.
So what about load management? Are we just talking about an app that counts how many minutes someone played in a game?
Oh no, far from it. Elite load management involves microsensors literally sewn into the players' jerseys.
Sewn in?
Yeah, they track explosive sprints, the G-force of their decelerations, their heart rate variability. I mean, they track their physical output down to the decimal point.
That is insane.
And then the AI cross-references that daily physical load with their sleep data and hydration levels. It detects the earliest physiological signs of fatigue long before the player actually feels tired.
I have to admit, from a purely technological standpoint, that sounds like magic.
I hear you. And from a purely physiological standpoint, that tech actually does work.
It really prevents injuries.
It really catches tears before they happen. The system will alert a coach and say, hey, player X's left leg deceleration metrics have dropped by 4% and their landing mechanics are deteriorating. Sit them down today or they will pull a hamstring tomorrow.
Wow.
Yeah. The problem isn't the technology's effectiveness,
Yeah.
It's the economic gatekeeping. Deloitte notes this elite baseline is expected to trickle down to youth sports.
Yeah, I have to push back on the tech optimism of that whole trickle-down theory.
Fair enough.
Because, sure, predicting injuries sounds great. As a society, we obviously want to protect kids. But who actually gets to use this? This is where the numbers get really sobering.
They really do.
Steyn brings in a recent report from the San Francisco Chronicle that perfectly illustrates this problem. They looked at a youth soccer club in the U.S. that actually implemented this stuff.
Right, the full AI setup.
Yeah. They used the AI video analysis, the heart rate monitors, the wearable tracking tools. Do you know what the cost was?
It creates a staggering barrier to entry, I know that.
It was an extra $300 per player, specifically just for the tech. And that was on top of a $3,200 annual club fee.
That is just, it's large.
$3,500 a year for a kid to play soccer. Steyn's core thesis is basically, look, that might be a manageable expense in highly affluent settings like certain suburbs in the U.S.
Right.
But it is completely unrealistic for most families in South Africa and, frankly, across the entire African continent.
If we connect this to the bigger picture, an innovation that only serves the top 1% of the economic spectrum isn't actually revolutionizing youth sports.
No, not at all.
You are taking the inherent inequalities that already exist in sports funding and infrastructure, and you are just turbocharging them with technology.
We are essentially saying, hey, we have the technology to keep your child from tearing their ACL, but only if you can afford the premium subscription.
Exactly.
We are building a massive paywall around child safety.
Which is the uncomfortable truth Steyn is forcing us to confront. If the conversation about AI in youth sport remains limited to elite academies, it changes absolutely nothing for the average child kicking a ball on a dusty, uneven field in Pretoria.
So, using constant sensor-based monitoring is economically unviable for most of the world. That's a given. But we can't just throw our hands up and say, well, no text for anyone, let the kids get hurt. What does practical, affordable AI actually look like in a developing context?
This is where the concept of an African reality check becomes constructive.
Okay.
Steyn highlights the work currently underway through the Reform Network's Athlete Health Project in Africa. Their approach flips the whole Silicon Valley model on its head.
How so? Paint a picture of what a Reform Network practice looks like compared to that San Francisco club.
Well, instead of starting with expensive gadgets and trying to force them into a low-resource environment, they start with the realities of the environment itself.
Got it.
In San Francisco, you have kids pulling on sensor-woven vests that need to be charged and connected to a high-speed Wi-Fi network before practice even begins.
Right, all the bells and whistles.
The Reform Network ditches the high-end wearables entirely. They focus on adapted injury prevention resources. We are talking about multilingual education materials and practical awareness campaigns.
So paper instead of sensors.
Basically, a coach in a rural community might have a laminated sheet translated into the local language that details a specific 20-minute neuromuscular warm-up routine.
But wait, how does a multilingual pamphlet or a laminated sheet prevent an ACL tear better than a wearable sensor?
Because injury prevention doesn't start with a microchip, it starts with teaching the body how to move. Neuromuscular warm-ups train the nervous system and the muscles to react properly. They teach a kid how to balance, how to strengthen their core, and crucially, how to land from a jump without their knees collapsing inward.
And that really works.
Studies consistently show that simply performing these specific low-tech warm-up routines can reduce severe injuries by up to 50%.
50%.
Yes, and it requires zero electricity, zero sensors, and zero subscription fees.
Okay, I love the old school practicality of that. But where does the AI fit in then? If you don't have sensors strapped to every kid, what is the computer actually analyzing?
Practical AI in this context uses what is already in people's pockets. A realistic starting point is simply smartphone video.
Yeah, just a normal phone camera.
Yeah, a coach can set up a standard smartphone on a cheap tripod. They might use one shared device for the whole team. They use basic load tracking sheets, literally writing down on paper how many high-intensity sprints a kid did that week.
And then what? Who is looking at that video?
The coach uploads that smartphone video to a cloud-based AI tool when they have a stable connection.
Oh, so it's not real time.
No, it acts as an occasional AI-assisted review. The software runs that same kinematic mapping we talked about earlier, creating a digital stick figure from the standard video to analyze the landing pattern.
So it does the same math, just from a regular video.
Exactly. It provides a second opinion to double-check the coach's own visual assessment of a player's running mechanics.
It's the difference between a Swiss Army knife and, like, a $50,000 laser-guided pneumatic torque wrench.
That's a great way to put it.
The laser wrench, that's the elite AI setup, is incredible if you're building a spaceship in a sterile lab. But if you're just trying to tighten a loose screw on a bicycle in your driveway, the Swiss Army knife is what actually gets the job done.
Right.
The smartphone video and basic tracking sheets are tools you can actually carry and use every single day out in the real world.
That analogy hits the nail on the head. Steyn argues that a tool that goes unused because it's too complex, requires massive bandwidth, or breaks and can't be repaired locally is utterly useless.
Just a paperweight.
Exactly. AI should always support human coaching judgment, not replace it. Technology is only useful if a coach actually understands what to do with the information.
So using a smartphone to record a player's stride solves the hardware cost. That's great. But it creates a brand new invisible problem.
The data problem.
Yeah. When that coach uploads the smartphone video of a 12-year-old to a cloud-based AI, where exactly is that video going? What is the hidden cost to a child's privacy?
We are moving from the economics of hardware to the ethics of software, which is incredibly murky territory.
Very murky.
La Liga Business School recently published stark warnings about this. They highlighted the profound problems of bias, transparency, and algorithmic decision-making when it comes to sports technology.
Break down algorithmic decision-making for us. How does that actually play out in youth sports?
What's fascinating here is understanding how an algorithm actually learns. Algorithms are trained on massive data sets.
Right.
Historically, the vast majority of sports biomechanics data has been gathered from adult, elite male athletes in Europe and North America.
Oh, I see where this is going.
Yeah. So the AI establishes its baseline of what a normal or safe movement looks like based on an adult man.
And obviously, an adult male professional athlete has a completely different body than a kid.
Vastly different. An adult male pro has massive quad and hamstring muscles that stabilize his knee joint in a very specific way. Now, take a 12-year-old girl in South Africa who is going through a rapid growth spurt.
Right, her whole body is changing.
Exactly. Her limbs are lengthening, her center of gravity is changing weekly, and she likely has hypermobile joints, which is incredibly common and normal at that age.
So if the AI applies the adult man's mathematical baseline to the young girl,
it is going to flag her normal developing movements as high-risk errors. The bias is built into the foundation of the code.
that's a huge problem.
It is. The algorithm looks at her hypermobile knee bend, compares it to a 25-year-old Premier League player, and sounds an alarm. And this leads to the specific danger Steyn highlights. An AI flag is not a medical diagnosis.
Here's where it gets really interesting and honestly kind of terrifying.
Yeah.
Think about that 10 or 12-year-old kid. What happens when people start treating the AI's output as gospel? What happens when that kid gets flagged by a piece of cheap software as being injury-prone or fragile?
It becomes an algorithmic scarlet letter. A child could be categorized and sidelined purely on the basis of flawed data.
Does that label follow them to high school? Like, does a scout look at a digital dashboard and decide not to recruit a teenager before they've even fully grown, just because an algorithm flagged their landing mechanics 3 years ago on a dusty pitch?
This raises an important question about the permanence of data. And it brings us to a concept discussed in a recent Frontiers article that Steyn cites: athlete data sovereignty.
Okay, athlete data sovereignty. That's a heavy term for a middle school soccer game. Let's ELI 5 that. Explain it like I'm 5.
Data sovereignty basically means whose property is your body's data.
Right.
And we are talking about minors here. Once a child's biometric data, the minute details of their biomechanics, their fatigue levels, once that enters a corporate server, who actually owns it?
That's a scary thought.
The Frontiers article emphasizes that parents must start asking very pointed questions about who is storing this data and who has access to it.
Because the real-world stakes are huge.
Yeah.
Think about it. If your kid takes a math test, that piece of paper stays in a locked filing cabinet at their middle school.
And eventually it gets thrown away.
Right. But if an AI wearable or a cloud-based video tool tracks your kid's physical vulnerabilities and labels them with an injury probability, that data lives forever on a server owned by a private tech startup.
And we live in an era where data is the most valuable currency on Earth. Startups get bought and sold constantly. Are these tech companies legally allowed to sell anonymized biometric data to third-party data brokers?
Wow. Imagine if that startup gets bought out by a massive health insurance conglomerate 10 years from now.
It happens all the time.
Could your kid's childhood injury-prone label, generated by a biased algorithm when they were 12, result in them paying higher physical therapy or health insurance premiums when they turn 25?
It sounds dystopian, but it is the logical endpoint of unregulated data harvesting. We really have to think critically about the long-term implications of turning childhood sport into a zone of constant digital surveillance.
That surveillance aspect is so completely counter to what youth sports are supposed to be about in the first place. You're out there to learn teamwork, get some fresh air, make mistakes, and grow as a human being, not to be, optimized and monitored like a factory machine on an assembly line.
Which brings us right back to Steyn's central argument regarding the African reality check. For schools and community clubs anywhere in the world, the smartest path forward is not to desperately chase every new blinking device.
No, definitely not.
It is to focus heavily on practical, human-led prevention, first, like those neuromuscular warm-ups we talked about, and then selectively use affordable digital tools only where they genuinely add value and respect the athlete's privacy.
So what does this all mean? Let's distill this down. If you are listening to this right now, whether you are a parent filling out registration forms for a local league, an amateur athlete, or just someone fascinated by how technology is bleeding into every corner of our lives, the real test for AI in sports isn't how slick a 3D skeletal rendering looks on an iPad Pro.
Not at all.
The real test is whether the tool is actually affordable, understandable, and fair for ordinary kids.
Steyn's closing thought provides a vital anchor for this whole conversation. We have to actively resist the deeply ingrained modern assumption that more data automatically means better sport.
Because it doesn't.
It doesn't. Sometimes more data just means more noise, more expense, and more anxiety for everyone involved.
We should absolutely welcome tools that help kids train safely. Nobody wants to see a kid get hurt on the field.
Of course not.
But we have to advocate for shared access models and basic education first. We need community pilots that test what actually works on the ground. We cannot let elite programs hoard the benefits of innovation while everyone else is left behind, or worse, allow tech companies to mine our children's physical data for profit.
Well said.
As Steyn says, particularly in the developing context, the future won't belong to the fanciest, most expensive system. It will belong to the most practical, inclusive, and human-centered one.
Ultimately, it is about preserving the human element of coaching and playing. And artificial intelligence can calculate the exact angle of a knee joint to the millimeter, but it cannot understand the heart, the grit, or the resilience of a young athlete.
The technology must serve the player, not the other way around.
Exactly.
Which brings me back to that kid we talked about at the very beginning, the one sprinting down the wet grass, pushing themselves to the absolute physical limit because they just love to play.
Yeah.
We want to protect that kid. But I want to leave you with this final thought to mull over. Let's say we do it. Let's say 10 years from now, we develop a cloud-based AI that is absolutely flawless.
Okay.
It costs $3, it has zero bias, and it can perfectly predict a child's exact athletic ceiling and their exact injury risk by the time they are 10 years old.
That would be something.
But does having that perfect omniscient data actually protect them? Or does mapping out their exact physical destiny on a spreadsheet completely destroy the fundamental magic, the hope, and the sheer unpredictability of playing the game in the first place? Think about that next time you're standing on the sidelines.